mechanically held lighting contactor can be connected to a photocell using these steps. Firstly, energize the contactor coil. Connect one side of the contactor coil to the neutral wire. Connect the other side of the contactor coil to a source of alternating current voltage, typically 240 volts. Secondly, control the contactor coil. Connect the normally open contact of the photocell in series with the contactor coil. When the photocell detects darkness, closing its contacts, it will supply power to the contactor coil, energizing it and closing the contact to contacts. Thirdly, connect the load. Connect the load, for example, street lights, to the contacts of the contactor. When the contactor is energized, the load will be supplied with power. Fourthly, optionally bypass the contactor coil. To allow the contactor to operate even when the photocell is not detecting darkness, connect a switch or timer in parallel with the contactor coil. This will bypass the photocell control and keep the contactor energized. Ensure that the contactor is rated for the load current and voltage. Use appropriate wiring and connectors to ensure a secure and safe connection. Consider using a surge suppressor to protect the contactor from voltage spikes. The materials needed include mechanically held lighting contactor, a photocell, and wiring. Let's delve deeper into the components and wiring practices involved in this setup. The mechanically held lighting contactor is an electrically controlled switch designed for applications requiring maintained contact positions without continuous coil energization. Unlike standard contactors, mechanically held contactors use a latching mechanism to maintain their state, reducing energy consumption and heat generation. These contactors typically have two coils, a latched coil and an unlatched coil, which control the contactor's position. The photocell, also known as a photoelectric sensor or light sensor, is a device that detects the presence or absence of light. It uses a photosensitive resistor or semiconductor to vary its resistance based on the amount of light it receives. In lighting control systems, photocells are commonly used to switch lights on at dusk and off at dawn, providing automated and energy-efficient operation. The wiring used in connecting these components must be appropriate for the voltage and current levels involved. Generally, conductors should be sized according to the National Electrical Code, specifically Table 310.15b16, which provides ampacity ratings for conductors based on insulation type and ambient temperature. It is essential to use conductors listed and labeled for the intended use, and to follow all applicable electrical codes and standards. Now let's discuss the steps in more detail. When energizing the contactor coil, it's crucial to identify the correct terminals for the latch and unlatched coils. The voltage supplied to these coils should match the contactor's specifications, typically 120 volts alternating current or 240 volts alternating current. The neutral wire serves as the return path for the alternating current voltage, completing the circuit. When connecting the photocell, the normally open contact is wired in series with the contactor's latch coil. This means that when the photocell detects darkness, it closes its internal switch, allowing current to flow to the latch coil. The photocell's voltage rating should be compatible with the control voltage used, and the wiring connection should be secure and properly insulated. Connecting the load involves wiring the street lights or other lighting fixtures to the contactor's output terminals. The contactor's current rating must be sufficient to handle the total current drawn by the load. Each lighting circuit should be protected by an overcurrent device, such as a circuit breaker or fuse, to prevent damage from short circuits or overloads. The optional bypass switch provides a manual override for the photocell control. This can be useful for testing the lighting system or for situations where continuous lighting is required regardless of ambient light levels. The switch is wired in parallel with the photocell, so when the switch is closed, it provides an alternate path for current to flow to the contactor's latch coil. To ensure safe and reliable operation, several additional factors should be considered. Firstly, verify that the contactor is rated for the appropriate voltage and current levels. The contactor's voltage rating should match the supply voltage, and its current rating should exceed the maximum current drawn by the load. Secondly, use appropriate wiring methods and connectors. All wiring should be installed in accordance with the National Electrical Code and local electrical codes. Use appropriately sized conductors, properly insulated connectors, and secure wiring practices to prevent loose connections or insulation failures. Thirdly, protect the contactor from voltage spikes. Voltage spikes can damage the contactor's coils or contacts, leading to premature failure. A surge suppressor can be installed in parallel with the contactor coil to absorb voltage spikes and protect the contactor. Fourthly, consider using a timer in conjunction with the photocell. A timer can be used to turn off the lights at a specific time, even if the photocell is still detecting darkness. This can help conserve energy and reduce light pollution. Fifthly, label all wiring and components clearly. This will make it easier to troubleshoot the system in the future. Use wire markers or labels to identify each conductor and component, and keep a wiring diagram handy for reference. Sixthly, inspect the system regularly. Periodically inspect the wiring, connectors, and components for signs of damage or wear. Tighten any loose connections and replace any damaged components promptly. Seventhly, use a licensed electrician. Electrical work can be dangerous, so it's always best to hire a licensed electrician to perform the installation. A licensed electrician will have the knowledge, skills, and experience to install the system safely and correctly. Eighthly, comply with all applicable codes and standards. The installation must comply with all applicable national, state, and local electrical codes and standards. These codes and standards are designed to ensure the safety and reliability of electrical systems. Ninthly, document the installation. Keep a record of all wiring, components, and settings. This will be helpful for troubleshooting and maintenance in the future. Tenthly, test the system thoroughly. After the installation is complete, test the system thoroughly to ensure that it is working properly. Verify that the lights turn on and off as expected, and that all safety features are functioning correctly. In summary, connecting a mechanically held lighting contactor to a photocell requires careful planning, attention to detail, and adherence to safety precautions. By following these steps and considering these additional factors, you can create a reliable and energy-efficient lighting control system. Also, ensure the mechanically held contactor is the correct type. Mechanically held contactors use a mechanism to maintain their contact position, either open or closed, without continuous power to the coil. This type of contactor has two coils, one to close the contacts and one to open them. This is important for energy conservation as it doesn't require constant power to maintain the circuit state. The wiring used should adhere to the National Electrical Code, specifically Article 310. The appropriate wire gauge is determined by the ampacity required for the connected load and the insulation type of the wire. Overcurrent protection, such as fuses or circuit breakers, is essential to protect the wiring and equipment from overloads and short circuits. The size of the overcurrent protection device should be chosen according to the ampacity of the conductors and the requirements of the connected load. Proper grounding is crucial for safety. The grounding system should comply with Article 250 of the National Electrical Code, ensuring that all metallic parts of the electrical system are properly grounded to provide a low impedance path for fault currents. The photocell specifications must match the control voltage requirements of the mechanically held contactor. Photocell typically operates on 120 volts alternating current, but other voltages may be used. Ensure the photocell is rated for the correct voltage to avoid damage. The location of the photocell should be carefully considered. It should be installed in a location where it is not obstructed by trees, buildings, or other objects that could prevent it from accurately sensing ambient light levels. Regular maintenance is essential to ensure the continued reliable operation of the system. This includes inspecting wiring, connections, and components for signs of wear or damage. Clean the photocell lens regularly to remove dirt and debris that could affect its performance. Use appropriate enclosures for all electrical components to protect them from environmental conditions such as moisture, dust, and corrosion. Enclosures should be rated for the specific environment in which they are installed. Clearly label all wiring and components to facilitate troubleshooting and maintenance. Use wire markers or labels to identify each conductor and component, and keep a wiring diagram handy for reference. The mechanically held contactor should be installed in a location that is accessible for maintenance and repair. Provide adequate clearance around the contactor to allow for safe and easy access. Consider using a surge protection device to protect the mechanically held contactor and other electrical components from voltage spikes and surges. Surge protection devices can help prevent damage to equipment and reduce the risk of electrical fires. Consider adding a manual override switch to the circuit. This switch would allow you to manually turn the lights on or off, regardless of the state of the photocell. This can be useful for testing the system or for providing additional lighting when needed. Ensure that all wiring connections are properly tightened and secured. Loose connections can cause overheating, arcing, and other problems. Use appropriate connectors and terminals to ensure secure and reliable connections. When working with electrical systems, always follow safe work practices. To energize the circuit before working on any wiring or components. Use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards and take steps to minimize the risk of injury. If you are not comfortable working with electrical systems, hire a qualified electrician to perform the installation. Electrical work can be dangerous, so it's always best to leave it to the professionals. The photocell should be mounted facing north in the northern hemisphere. This helps to prevent the photocell from being triggered by direct sunlight, which can cause it to turn the lights off prematurely. The sensitivity of the photocell may need to be adjusted depending on the location and application. Refer to the manufacturer's instructions for guidance on adjusting the sensitivity. Consider using a time delay relay in conjunction with the photocell. This will prevent the lights from turning on and off rapidly due to momentary changes in light levels, such as passing clouds. Ensure that the mechanically held contactor is properly sized for the load it will be controlling. The contactor should have a current rating that is greater than the total current draw of the lights. Use flexible conduit for wiring connections to allow for movement and vibration. Flexible conduit can help prevent damage to wiring and connections. Consider using a programmable logic controller or PLC to control the lights. A PLC can provide more advanced control features, such as scheduling and dimming. Review local codes and standards. Always consult with a qualified electrician to ensure that the installation complies with all applicable codes and standards. Be aware of the voltage drop in the wiring. Voltage drop can cause the lights to be dim or not work at all. Use appropriately sized conductors to minimize voltage drop. Consider using light-emitting diode or LED lighting. LED lighting is more energy efficient and has a longer lifespan than traditional lighting. Use a three-way switch. You can add a three-way switch in parallel with the photocell to allow for manual control of the lights from two different locations. Test the system under different lighting conditions. Test the system at dusk, dawn, and during the day to ensure that it is working properly. Observe the lighting circuit to verify proper performance. After installation, periodically observe the lighting circuit to ensure it continues to function as designed. Address any issues promptly to maintain system integrity. A surge arrestor is recommended. Use a surge arrestor at the electrical panel to protect the lighting system from voltage surges caused by lightning or other electrical events. The lighting system's operating temperature should be considered. Ensure that all components of the lighting system are rated for the operating temperature range of the environment in which they will be installed. Consider using a wireless control system. A wireless control system can allow you to control the lights remotely, using a smartphone or other device. Install a disconnect switch. Install a disconnect switch near the mechanically held contactor to allow you to safely disconnect the power to the contactor for maintenance or repairs.